Welcome to today's Lunch and Learn webinar, Reducing Engineering Costs by Integrating CAD and ERP Data, brought to you by ArcherPoint and Elmo Solutions. One of the most expensive aspects of any engineering project is data integration. Elmo Solutions, a leader in ERP-CAD data integration, offers a solution, AgniLink. AgniLink is one of the most advanced CAD to ERP data integration systems currently available. As an add-in to AutoCAD, SolidWorks, or Autodesk Inventor, AgniLink offers a unique, reliable, and cost-effective way to integrate CAD, PLM applications with Microsoft Dynamics NAV and virtually all ERP systems. Our presenter today is Ricardo Talbot. Ricardo has 33 years experience with engineering and manufacturing and is a renowned expert of CAD to ERP data integration. He is the founding CEO and Science Officer of Elmo Solutions. His endeavors led to the successful development of groundbreaking applications such as AgniLink, Agni Enterprise Search, and Elmo Bill of Materials, with 48 users in 48 countries. In today's webinar, Ricardo will demonstrate a unique and reliable way to integrate PDM and ERP data, automatically resolving discrepancies and allowing editing of CAD and PDM data using values obtained live from the ERP application. He will show the perfect synchronization of both data sets, which completely eliminates redundant data entry as well as costly errors. Ricardo will also show how AgniLink can process and synchronize a wide range of product data from either environment. So let's go ahead and get started. Ricardo, over to you.
Thank you, Suzanne, and thank you for inviting us today to present our solution. As Suzanne said, my name is Ricardo, and I'm here. My key position here is Science Officer, and in that regard, I am heading the R&D department at Elmo Solutions, and that's one reason why I insist on doing those presentations, because it's always a great opportunity to gather some input from existing and potential customers. So feel free, please, to give your input. If there's something there that you don't like, please say so. If there's something you would like to see, all the more reason to say so. So I'm really thrilled to be with you today. The theme here is, why should you integrate your CAD and ERP data? And if you are an engineered order intensive manufacturer, well, let me spill the beans right away. Plain and simple, the reason is because it might help you reduce your engineering costs by up to 20%. From our experience, anywhere between 5 and 20% of the total engineering time is spent just in the process of transcribing manually or through some kind of export-import scheme the bill of materials data from the computer-aided design system into the manufacturing management system, usually an ERP system. And what our solution does basically is to help automate the process of transferring those engineering bounds and turn them into manufacturing bounds. Let me talk briefly about who we are. Elmo Solutions is a subsidiary of Erisco, which was founded in 1976. And the Erisco group overall has 20 employees, so we're a pretty small organization. And we come from the CAD business, from the engineering environment, and we've been working with CAD applications since 1983. Actually, Erisco is the most experienced Autodesk partner still in existence in Canada. We're headquartered in, as you can possibly hear, the French part of Canada in Quebec City. And we've been also working with ERP systems since 2008. Basically as a Microsoft Dynamics partner. And Elmo Solutions was founded out of the realization by the Erisco people that their customers did not get the most out of their investment in CAD metadata. What we call metadata is basically CAD data that does not have a geometric representation as such. So we're talking, for example, in the case of the AutoCAD drawings, attributes found in blocks. In the case of SolidWorks and Autodesk Inventor documents, we're talking about properties or I properties in the case of Inventor. And it was found that there had to a need for tools to leverage that investment in metadata, essentially in most cases for the purpose of transferring engineering BOMs into the manufacturing management system. So initially we developed a solution that would batch extract all of the metadata from a wide range of different document formats, prepare that into an Excel file, and then import that into the ERP system. But eventually we found out that that approach had some significant flaws, and the key issue being the validation of data prior to sending it to the ERP system. So eventually we developed a new generation of solutions that would work in a bidirectional fashion, thus allowing editing and correction of data prior to sending it to the ERP system. And that needs a real-time bidirectional solution, and this is precisely what we have developed. So AgniLink, in a nutshell, is essentially an add-in to your CAD, PDM, or PLM application. And its purpose is to establish a live link, bidirectional link, between that engineering application and your manufacturing management, essentially an ERP system, always in real time, thus allowing the validation, the correct validation of data prior to exporting to the ERP system, and also using the benefits of bidirectionality, being able of not only bringing data from CAD to ERP, but also back from ERP to CAD. So that means, for example, that you might be able to make costing data or vendor information available to your designers in real time. It could even be availability information to allow them to make the proper design decisions by having information that was essentially available only from the ERP system until now, available to them. The benefits of CAD to ERP integration in a bidirectional real-time fashion are numerous, but they can all be summarized into a very, let's say, short list of chosen few. One of them is, of course, the elimination of manual BOM transcription. And that also applies if you are currently working that process using an export-import kind of process. That process is tedious, it's error-prone, just like manual BOM transcription, and the elimination of that process, or let's say a great reduction of the effort put into that process, is usually sufficient to bring a really nice return on investment, as our ROI assessment calculator shows typically. But actually, the greater share of the ROI comes not really from the elimination of BOM transcription, but actually from the benefits derived from an increased BOM accuracy. Among other things, a more accurate BOM, because some of the transcription errors and inaccuracies are suppressed, will translate into less errors on the shop floor, thus improving the quality of the product and also the delivery. And also it will translate typically into a much better yield of raw materials, less scrap on the shop floor. In most cases, the recovery period is about anywhere between 3 and 6 months. So we're usually making a decision if for a customer who actually needs it, and we're really targeting here engineer-to-order manufacturers, the ROI rarely exceeds 6 months. The recovery period rarely exceeds 6 months. And that's based strictly on the elimination of BOM transcription. That's not counting the benefits derived from increased BOM accuracy. However, we all know some of these horror stories where the wrong raw material was used at the wrong time, and so that still enhances further the ROI. It's important to mention also that this solution, as opposed to the export-import process, for example, allows the both the customer and the end user to have complete control over the process. At all times, the end user can decide what is going to be done in the context of the integration using what we call the integration dashboard. Moreover, the way that the solution works is completely configurable by the end user, by the customer, sorry, using what we call the AgniLink configuration builder. And that is important. You can add new mappings, you can remove mappings, modify existing mappings, not only the mappings, but also the behavior that those mappings will adopt in the integration dashboard. And that can be done without any programming whatsoever, with the possible exception of very simple SQL, SQL queries, and all under customer control. So it's possible to completely change the way that the integration will work by simply changing the mappings in the AgniLink configuration, and without having to turn to the software developer, that's us, every time. We also have optional programs that greatly enhance the ROI on the solution. One of them is called the Jumpstart program. The Jumpstart is basically a program that includes virtually all of the implementation support services that a customer may need during the implementation phase of the integration. Normally it's completed from beginning to end within 20 business days, and it includes all of those services such as end-user training, administrator training, consulting on the and advice on the best business practices regarding how to integrate engineering and manufacturing data. It also includes validation of the technological environment and coaching about what has to be done to prepare the environment for the integration, which is usually no big deal in terms of technological effort, but has to be planned carefully. And it even includes, for those customers who want it, and after the fact ROI to reassure the person who signs the checks. And it's all done for a fixed fee. So you know in advance how much it's going to cost, and there's no surprises. We also have another fixed fee program called the Big Bang Bombs that is especially useful for those customers who wish to minimize the effort associated with the initialization of item and bill of materials data by extracting in batch mode the metadata found in those legacy CAD documents. We bring all of that data into one single Excel file that the customer can use to easily rework the data, select what data should be kept, what should be left out, and then we have a special connector that will basically read what we call the super bomb found in that Excel file and bring it all into the ERP system in one single operation using the AgniLink integration dashboard that will ensure that all of the data has been properly validated prior to being brought into the ERP system. And that translates, of course, into dramatic savings in terms of data validation and data entry or transfer to the existing ERP system. And again, that is done for a fixed fee. This is I would say this is a typical example of an ROI assessment that was done for one specific customer. In this case, the ROI, the recovery period is really excellent because usually the more users you have, the better is the recovery period. So in this case, we're even below the 3-month period. It gives you an example of the kind of investment that may be required. For this one is really a substantial implementation at 10 users. We have customers who have as many as 25 users, and some have only 1 user. But typically, it's really in that range. Take note that not all users, not all CAD users necessarily have to use the application. You really want to have that application available for those users who are enabled to release new product to manufacturing. In some cases, we have some customers who are really keen on using the benefits of bidirectionality to use the ERP data to populate the CAD data during the design process, which was really great, because by merely entering just an item number, you can ask AgniLink to get all the data from the ERP system and populate the engineering documents with that data, which is great. But this is not essential. This is something that may come afterwards. But initially, you want to have AgniLink clients available to those end users who are, as I said, unable to release product. So this is a typical example of the kind of ROI we can expect in an ATO environment. Typically, as I said, it's anywhere between 5 and 20% of the total engineering effort that is devoted to that to the transcription of data. Note also the TBD mentioned here. This does not take into account the losses on the shop floor. AgniLink is a connector-based application, and as such, it offers connectors for different CAD and ERP platforms. Let me say that the Microsoft Dynamics platform is dear to our hearts because it was the first platform for which we actually developed CAD to ERP integration. Actually, it was Dynamics NAV, and eventually the other three Dynamics ERP platforms followed suit. We're engaged in an effort to diversify our clientele by developing new ERP connectors. But again, Microsoft Dynamics is definitely the strategic platform for us. We also have a wide range of connectors for CAD, PDM, or PLM applications. We have just finished the Siemens Solid Edge connector, which is currently undergoing beta testing. We'll soon begin working on the PTC windshield platform. We have finished the Autodesk Rivet connector a few months ago. It's working great. We already have customers who are very happy with it in both the United States and Australia. And the ROI with the Autodesk Rivet connector and Dynamics NAV is really amazing. Because of course there's, especially in the case of manufactured homes, because as those who know that industry know that this is 110% engineer to order. I think it's good to know that although 90% of the time what we're asked to do is basically about bills of materials and items, by merely changing the AgniLink configuration, it is possible to completely change the behavior of the system. So for example, you might be making product and also doing implementation plans or layouts for that product. So you might use two different configurations, one for the integration of items and bills of materials between the CAD and the CAD design, product design documents and the ERP system, and you might want to use a distinct configuration that would integrate the layouts with, for example, quotes or estimation application in the ERP system. So it's merely a matter of changing the mappings and changing the tables that are involved, so to speak, in both cases. Let's take a brief look at the architecture. As you can see, it's no rocket science. What we have basically is the core of the application here, which is called, for lack of a better word, the Elmo API, which is basically the core code of AgniLink, and also it contains the data objects that are used during the integration. You could see the AgniLink data model as a three-bucket system. You have a CAD bucket, you have an ERP bucket, and then you have the AgniLink bucket. So anytime that you trigger the integration process through the connectors, which work pretty much in the same way as drivers in Windows environment, for example, AgniLink will get the data from both the CAD system and the ERP system and put them into those respective buckets. Let's call them number 1 and number 3. It will automatically resolve the discrepancies based on rules that are preset in the AgniLink configuration and that can be changed by the customer at any time. And once the discrepancies are resolved, it will put the data in bucket number 2, where it will be exposed to the integration dashboard, the AgniLink user interface basically, to allow the end user to do some further changes on the data and make sure that whatever will end up in the ERP system is appropriate. So we added some really nice functionality that allows quick manipulation of the data. We always bear in mind the fact that the engineering users are the main contributors to the integration, but they are not necessarily the main beneficiaries. So we want to make sure that we're not going to annoy them and we're going to make their job easier and not harder because of the integration process. So again, this is really no rocket science. It's a very simple system. It's very complex inside, but overall it had to be simple from the very beginning. So we offer a wide range of CAD connectors and ERP connectors, and changing the connector allows the customer to have the same consistent user interface throughout all CAD and ERP applications used. So let's see how it works. For the sake of today's presentation, we're going to use SolidWorks as our CAD application and Dynamics NAV as our ERP application. Notice that the ERP the database here is totally void of any of my own items. This is actually the good old Cronus database for those familiar with NAV. So there are some items in there. However, there are no items that have been created or processed by the integration. So what we're going to do first and foremost is we are going to complete our integration and automatically populate the items in the bills of materials with whatever has been found in the engineering document. Now, how is the integration triggered? It is triggered basically by different events depending on the CAD, PDM, or PLM application. In the case of a CAD application, it's usually a save operation that will trigger the synchronization. Now here you have the AgniLink toolbar. Notice that the first two buttons are to activate or deactivate the application. So at any time you can deactivate AgniLink and nothing really will happen from an AgniLink standpoint at save time. Whenever you activate AgniLink, then AgniLink will trigger, in the case of a CAD application such as SolidWorks, it will intercept the save message, and it will do its processing prior to letting the CAD application complete the save process. That allows us to do any changes that have to be done within the CAD documents prior to the save that is done by the CAD application. The toolbar will also allow me to force a manual save here, but actually it's just exactly the same thing as doing a Control-S or a file save in the CAD document. It will allow me also to select synchronization options. That's quite interesting because this will allow you to determine what is going to happen in terms of updating the CAD or the ERP data whenever you trigger the synchronization process. So for example, it's possible to say, okay, I'm going to want to update my CAD data, but not the ERP data. Why do you want to do that? Perhaps you will want to make your designers as lazy as possible, which is a great quality, and allow them to populate their data by using what is found in the ERP system and by merely entering an item number, and then AgniLink will offer them the option of downloading the data for that specific item from the ERP system, which will increase, of course, the consistency that is brought into the engineering data during the design process. So you're not really ready to release that product for manufacturing, but still you can benefit from the bidirectionality of the integration by progressively bringing that data into the engineering system. You might want to do the opposite, perhaps, not necessarily update your CAD documents, but just sync with the ERP to create those new items that are created during the engineering process. You might also want to use the no-sync option. Why would you want to use the no-sync option? Simply because it will allow you to still do a validation using the lookups that we're going to show later on. Those lookups will allow you to do the validation of your data against the data in the ERP system without doing any update whatsoever, neither on the ERP system nor on the CAD system. But of course, the high road is to synchronize both your CAD and ERP data at the same time, and this is what we're going to do in this first example here. You also have an options button here. Clear and simple, the number of options available are quite limited because actually it's a highly automated system. So again, because we do not want to confuse the end user with tons of settings, we try to automate the process as much as possible and keep the options to a minimum. One of these options will allow you to determine whether or not you want AgniLink to process those thumbnails, those pictures you see when you look at a CAD document in Windows Explorer. This is important because it usually consumes quite a lot of CPU resources on the PC, and you may not necessarily want to use that. But of course, it's a great feature because what it does basically is that it will extract from each and every BOM item in the engineering department. It can extract the picture and then use that picture and send it into the picture field in your ERP system whenever that feature is available. And of course, it is available with applications such as Dynamics NAV and Dynamics AX, among others. There are some other simple options. One of them, which is very important to your engineering users, in the case of SolidWorks, will allow the end users to determine whether those, what we call the custom properties, which are basically the fields that are mapped to your ERP fields, whether they will be taken in the active document or in what we call the active configuration. This is very important because depending on how your engineering department people work, their metadata for the ERP system will be found in either the active document compartment or the active configuration compartment. Another interesting thing, if you're using a PDM system, such as, for example, by the way, PDM stands for Product Document Management, which is basically a superset of a CAD application. And in the case of a PDM system, the end user will be able to select what we call the states or the workflows that change and define the state of a document. Usually they will probably want to trigger the integration when a document approval or release has been done. However, it is possible to select any of these workflows or states to trigger the integration. Sometimes you will want to do the integration progressively as the system is built. It can be done by merely selecting the proper states and workflows. Another great feature of the system is what we call the AgniLink configuration builder that I mentioned earlier. So what it is basically is a utility that will allow you to define the behavior of the system of the integration by merely modifying a grid of properties here that we call the mappings. Actually, mappings are grouped into what we call scenarios. So for example, and the scenario being basically what is going to happen when that specific type of document is processed in the CAD system. So we have a scenario for assemblies, we have one for parts, we have one for routings, and we also have a special one for bills of materials. The bill of materials scenario will be triggered automatically whenever an assembly is processed in the CAD system, or a part that has a raw material is processed as well. AgniLink will automatically make the decision as to how to process a part or an assembly depending on what is found in that document. In the case, for example, of an assembly, it will always be treated as both a BOM and an item, if we're talking about a BOM type integration in the ERP system, of course. So an assembly will always be treated as both an item and a BOM. However, a purchased part will be treated just as an item. In the case, for example, of a part that does have a raw material, because we do manage the raw materials as well, in that case, AgniLink will treat the part as both an item in the ERP system and also a BOM that would have an only child that would be the raw material. Now, those scenarios develop into mappings, and we call them correspondences actually. And those correspondences are basically a description of how the data is mapped between the ERP and the CAD system, and also the behavior of those mappings once they are found in the integration dashboard. So here you have to indicate, of course, the table and the field that will be used in that ERP system. In the case of the CAD system, you give the property, and the property set, which is actually, we stole that from Autodesk, but we still use it also for SolidWorks. It allows you to group your properties into similar that have similar characteristics, and that allows you to group the data in the dashboard. Very, very convenient, very useful. And we also have a special set of properties that is called the mass properties. That will allow you to extract automatically the mass from the CAD document. And let's say, for example, you have the magic formula that would allow you to calculate the weight based on the mass. You can do that calculation in AgniLink using what we call the expressions, basically. Each mapping can be associated with an expression. So we can extract the mass from the CAD system and then calculate any kind of weight, shipping weight, gross weight, net weight, and then send that calculated weight into the ERP system. And then we have a description of what we call the behaviors. So for example, let's say that you want to make sure that a specific field is populated properly prior to being sent to the ERP system. So you will indicate that this field is required in the ERP system and also that it is required in the form. You may also want to make sure that a field that is optional in the ERP system will be populated by the end user, and in that case you will uncheck the required in ERP field, of course, and check the required in form field, thus making sure that everything you want in your ERP system will be properly populated. Sometimes there's data that you want to have shared back and forth between the CAD and the ERP system, but you may not necessarily want to bother the user with that. It may be some internal, coding information or whatever. So you can simply say, okay, I don't want that data to be displayed to the user. And here's what we call the prevalence. That's how you determine if there's a discrepancy between what we have found in the CAD and the ERP system, what we're going to do about it. So we're going to resolve those, based on those rules, we're going to resolve automatically those discrepancies, but still, at any time, the end user always has the option of overthrowing, is that the proper word, that decision made by AgniLink and revert to a different value or manually enter a distinct value if required. So we have the CAD and ERP prevalence options, but we also have the if empty options, especially when you're working with legacy data. Sometimes you may want the ERP data to be prevalent, but it's empty at that time. Still, there's something in the CAD document. So you'll say, okay, I'll have ERP, except if it's empty, in which case we'll use the, the CAD data. You also have the possibility of, for each individual field, determining whether it's going to be read-write or read-only. This is especially useful, for example, for costing or vendor information. You may not want your engineering people to be able to modify that data. However, you want to make it accessible, so it's going to be visible, but it will not be, they will not be enabled to change that data, either in CAD, in ERP, or in the form. And then we have those lookups I mentioned earlier. For the sake of making sure that whatever ends up in the ERP system has been properly validated, it helps greatly to have access to those values that are legal in the ERP system. Let's say, for example, in the case of Dynamics NAV, the item type, which is crucial because I think it's called the inventory posting group in more savant words. And the purpose of that field is to indicate whether it's a raw material or a purchased part or a manufactured part we're working with. And this is, of course, crucial to AgniLink because that's one of the criteria used to decide how we're going to process that component. So you want to make sure that this field has been properly populated. It is mandatory in NAV. So you want to make sure that not only it is entered properly, but also it is entered only as a possible value of those values that are legal in the ERP system. So that's what you're going to use the queries for. Also, queries are very useful if you do use the raw materials in AgniLink. You will be excuse me, able to create a lookup or use a lookup actually in AgniLink that will return only those items excuse me, only those items from the ERP system that do qualify as a raw material. And using the keyword search feature, it's very easy then to find, even for a user who does not happen to know all of these item numbers by heart, it's fairly easy to find those raw materials in the item list, even if there are thousands of them. And then, of course, you can assign a default value. An interesting feature is that you can also assign a default value as being the previous one. So in cases where the value is pretty much always the same, except for a few exceptions, you might want to use that feature. But usually you will want to, of course, to assign that for the default values required by the ERP system. And then you have those expressions I referred to earlier that will allow you to use your mappings as variables and include those variables in expressions that will be used to generate new values that will in turn be part of the integration. Notice this expression here that is basically a concatenation of strings. We use that in the case of engineering departments that systematically generate a PDF, non-modifiable, or it can be PDF or actually any type of non-modifiable format document. We use that to find the fully qualified path name to that item in the PDF or the archive vault, and we can send that as a link to the ERP application so that, for example, drawings can be, links to the drawings can be stored for each individual item in your ERP system, thus giving your end users access to drawings of each individual item with the possible exception of raw materials. Actually, you could even do that with raw materials if you want, but that's not where it's most useful. And so you can have clickable links in the ERP system that will return the drawing. This is the expression I mentioned. It's a very simple one in this case that we use to calculate the weight out of the mass property, the mass actually of the component found in the CAD document. So this is pretty much what the configuration builder and AgniLink configurations are about. What's interesting also is that Sometimes you may want to define different configurations based on the user role in the organization. For example, you might want to enable some users to create parts and assemblies, and I should say items and BOMs in the ERP system. Sometimes you may not want to allow that for some users, but for others, yes. So you will define different custom configurations and distribute them based on the user role. So this is pretty much what the builder is about. Oh, and by the way, we're currently we're actively seeking beta testers for what we call the ERP simulator. Sometimes potential customers want to evaluate the product without necessarily involving their own ERP system, or perhaps in situations where the ERP system has not been selected yet. So we have just built a trial version of AgniLink that allows the customer to there you go. It's basically an ERP simulator that keeps track of the basic data that is required for bills of materials, items, and so on. So if anyone is interested in participating in the beta testing, we'll be more than happy to work with you on that. That pretty much concludes the control. So why don't we get some action here and launch the integration. So as I said, it's merely a matter of saving the CAD document. AgniLink will get the data from both the CAD documents, the parts and assemblies, and also from the ERP system. In that case, of course, since there's nothing in the ERP system, we're starting blank. And that explains, notice that we make extensive use of color coding so that the end user can be immediately made aware of what is going on with the integration. So for example, a green line here indicates that that product has not been found in that BOM item, I should say, has not been found in the ERP system. And when we complete the integration, it will be created automatically. The item number here is really the key that unites, so to speak, both our systems. And it's, I would say the golden rule is you can integrate anything you want between your CAD and ERP system as long as there is one key. That is most of the times the item number, but actually it can be a project number, a job number, or anything. But as long as you have a one-to-one relationship between that I should say line among your engineering documents and the matching items in the ERP system, as long as you have that one-to-one relationship, we're fine. So we have some fields here that are basically lookups. And you can find them easily because they have that button with the 3 dots. So for example, the item type here is a lookup. So let's say I want to enter a totally silly item type. Then the cell here, a red cell indicates an error. The cell will remain red. However, I have the option of clicking the lookup button here, and this will return in real time the legal values from the ERP system. So I'm going to say this is a finished part, which is true actually. Now of course we do not want to annoy the engineering people by having them enter manually all of that data. So we came up with a really nice copy and paste feature that they can use. Let's say though all of these components are finished, so that they can easily populate only when it's needed that data in the integration dashboard. And when we're done, of course, the content of the integration dashboard will be used to update simultaneously our CAD data and our ERP data. The same goes for units of measure here. That lookup is quite special because it will return only those units of measure that are applicable to that specific item, of course. So let's say, for example, that in this case I'm going to use, well, I already entered it, so I'm going to use a distinct, let's say this is sold in cans. And also notice that the copy and paste feature can be applied to irregular destinations. So I could say, for example, I want to copy that into this cell, and this cell, and it will be distributed in the order that it has that we have clicked those cells. But that would be a bit ridiculous. So I'm going to apply this only to those 2 cells here. There you go. The validation of the data is always done in real time unless you click this button here, in which case you will be able to expedite the process, because of course with some large assemblies this can take some time, so you can just disconnect it and manually validate your data. So as of now I still have 2 errors found here, right here, and I have an invalid raw material. And by the way, there's always a tooltip that tells you what exactly the error is. So in this case it says that this raw material was not found in the list of ERP possible values. So I'm going to use the lookup again. Now this time, rather than entering an item number, I'm going to use the keyword search feature. So I'm going to say, okay, I don't know exactly what I'm looking for, but I know it's a leg. So I'm going to click the description here, enter leg, and I'm lucky because I have only one in the item list here. So I'm going to select this. And here again, the units of measure shown are only those units of measure that are specifically applicable to that raw material. So I'm going to click that and say, okay, it's inches. There you go. Also notice the raw material quantity here. If in the case, for example, of what we call in SolidWorks cut list, a cut list has a depending on the type of cut list item, it can be, for example, a plate, or it can be I'm sorry, I don't know the exact term in English. It's a rod, for example, or a leg. It can extract automatically the length or the area of that part from SolidWorks, and that's what we do. And with the proper configuration item here, we can automatically extract that quantity from SolidWorks or from any other CAD application and use it as our raw material quantity. So if for some reason the geometry has changed, the length has changed, or the area, it will be updated automatically the next time you trigger the integration. All of this information that follows is really optional. It's something that has been added in the out-of-the-box configuration. So you have, for example, the vendor number. In this case, in this configuration, the end user is allowed to modify the vendor number. Yeah, the vendor number. I'm sorry. Copy and paste error here. There we go. Those are the calculated weights I referred to earlier, and this is those are the paths to my PDF documents that have been generated automatically by an expression. By the way, if a field, oh, not this one is not mandatory. So let's say, for example, once I have entered a raw material, the raw material units become mandatory, of course. So as long as I still have things that have to be corrected in the dashboard, AgniLink will just refuse to complete this synchronization to make sure that we can safely complete this integration. Now we do a final check, and we go for the real thing. This is going to happen pretty fast, so let's see if I can catch it in my ERP system. Yeah, you can see now my items being created in real time in the ERP system. By the same token, since all of these parts were manufactured parts and had a raw material, that means that I also created, not only for my top-level assembly here, but also for all of my individual parts, I have created a production BOM. So in the case of the assembly here, I have those child items here in the bill of materials, and the quantity is what has been extracted from the CAD document. So at any time if there are changes in those quantities, they will be automatically extracted the next time we synchronize the data and be sent to the ERP system. And we also have individual production BOMs with only one child item here for each of these manufactured parts that had a raw material, and the quantity is what I have extracted from the CAD document and sent to the integration dashboard. Now, let's see what happens if I change, for example, a description in an item here. So let's say that we have downgraded this heavy-duty leg here, and it's now become a light-duty leg. And then I'm going, oh, let me get rid of this here. There you go. Now let's see what happens the next time I trigger the integration process. A discrepancy will be found, of course, between the CAD description and the ERP description. So AgniLink will automatically find it, and it will indicate it by coloring the cell yellow. Now, as I said, at any time the end user has the option of deciding whether this is what he or she really wants, or can just simply right-click on the cell and say, okay, I want to revert to the previous, to the CAD version, so to speak, of the data. At all times, you can see the content of each of these three individual buckets. Another way you can see what you have in your integration, this is a simple view. We have a much more sophisticated view here that will show you all of the details relevant to each individual component, including even the picture for that that component. So anytime you select a row here, the content of the lower pane will change. There's also many more informations than what you can see right now in the dashboard, and that's most of the time I would say for troubleshooting or I'm sorry, fine-tuning or diagnostic purposes. But there's many more semaphores. Like, for example, there's a field that can be used, a checkbox actually, that can be used to exclude a part or an assembly from the ERP BOM. The reason why you want to do that is sometimes you would model a purchased assembly in your CAD system, and you may not want to have the detail, the lower components on the BOM sent to the ERP system. We call that sometimes a phantom BOM. So what you want to do is to keep the top-level assembly, and the rest will be left out of the bill of materials in the ERP system, and that flag is kept forever in the CAD documents. So there's a wide range of data, but on a day-to-day basis, usually this is the simple view that you're going to use. So long story short, my end user here has the option of selecting which of the three buckets will be kept, or simply to say, okay, I'm going to change that for a cheap leg, and then complete my integration. Now let's see what happened in my ERP system. Now my description has been changed to cheap leg. So that's how we can bidirectionally bring data back and forth between the CAD and the ERP system with maximum efficiency.
We do have a couple of questions that have come in, Ricardo.
Okay. Yep, I'm done.
Oh, good. Perfect.
Perfect timing.
So first of all, is AgniLink, is it compatible with NAV 2009 R2?
Yes, actually, it's compatible with any version starting with 4.0.
That's what I thought. Just wanted to verify that. Another question that came in is how well does it work with if AutoCAD is on a local machine but NAV is hosted?
That's not a problem because all of the communication with Dynamics NAV is done through web services, so it's cloud ready. It's been cloud ready even before there was such a thing as a cloud version of NAV. So that's not a problem. We have customers who work with either on-premise or cloud environments.
All right, great. Thank you for the questions. Let's see what else we have here. Well, we have a couple minutes left. When's the best time to implement CAD and ERP integration?
ASAP. and I know I'm preaching for my own parish, being born Catholic, but actually there's a good reason for that. There are a few good reasons for that. First and foremost, bear in mind the fact that sometimes I say connecting CAD and ERP is pretty much like connecting two lakes together, and they don't have the same kind of fish. Maybe you have more salt in one than another one, and you're digging a ditch to connect them together. There's some precautions that have to be taken, and there's an impact on both ponds. And that's pretty much what happens when you integrate CAD and ERP data. You have to involve different business processes, different people, and this has definitely an impact in virtually all cases. This has an impact on the system design. So it's better to plan ahead and take into consideration the properties and the capabilities of the integration system, because that will, at the end of the day, this will translate into dramatic savings in system design and implementation costs. There's also the fact that in many cases, customers will want to, rather than using, for example, if there's a legacy ERP system, rather than transferring data, importing data from the legacy system into the new system, they will want to start fresh. But starting fresh might also mean using, in as much as possible, leveraging the existing engineering metadata that sits, in huge quantities in those servers. So the Big Bang Bombs program, for example, will allow those customers to very cost effectively initialize at least the items and BOM data that is currently found in those legacy BOM documents. So that's all the more reason to plan ahead and make sure that the properties, the characteristics of the integration are defined as early as possible, because not only it has an impact on the system design, but it also has a dramatic impact on the cost of initialization of the ERP data. So that's, again, another reason why it should be done as early as possible.
So thank you so much, Ricardo. Very informative, and thank you, audience, for your questions. We do appreciate everyone setting aside some time out of their busy day for this webinar. We hope you consider it time well spent. Please do provide your feedback to info@archerpoint.com. Again, that's info@archerpoint.com with any questions, comments, or feedback that you may have, and suggestions for future Lunch and Learn topics. Again, thank you for your time, everyone. Ricardo as well. And this concludes today's session. Have a great rest of the day.
Thank you. You too. Goodbye, everyone.